Okay, so today we're going to be learning about graphing exponential functions. So some of the graphical features of exponential functions that we know that it's the equation f of x equals a b to the x. So what the a means in the graph is that that's the vertical intercept, which is at 0a. And b is at the rate at which it's increasing, which we know b is usually the rate. Some cool things though is that if b is bigger than 1, we're going to say that the function is increasing. And if it's basically between 0 and 1, it's decreasing. Another thing is that in its standard form, the graph has a horizontal asymptote at y equals 0, and it's always going to have a point at 1 and a times b. Okay? So in this first example, we're going to sketch a graph of the function f of x equals 4, 1 times 3. So I'm going to just start with identifying the things that I know. So first off, I know that it's got a vertical intercept at 0a. So my vertical intercept in this case is going to be at 0, and then my a value is 4, so 0, 4. And I'm just going to go ahead and graph that. 0, 4. There's my vertical intercept. The next thing that I know is that b is the rate it's increasing. So since 1/3 is between 0 and 1, this function is decreasing. I have that in green, lime green. And we'll use the right tool. Or maybe not lime green. Function is decreasing. Okay? And next, it has a horizontal asymptote at y equals 0. That is going to be the case for this problem because it's not adding anything else on, so it's not shifting at all. So I'm going to draw a dotted line at y equals 0. So this tells me that it's not going to cross here. And then the next thing I know that it's going to have a point at 1, a times b. So point a times b, a is 4 times 1/3, which is going to be the point 1 4/3. So I'm going to just go ahead and graph that point now. All right, so 1, and then 4/3 is a little bit above it, so it's going to be right there. And now that I have 2 points, I know that this graph is decreasing, which means as it approaches the horizontal asymptote, it's going to get really close to 0 but not touch it. So my actual function is just going to look like that. And that is a good sketch of this graph. And that's all you have to do. So you got to just identify the vertical intercept, say if it's increasing or decreasing, so you know what's going on, and then graph your point. Okay. So next, we're going to talk about transformations because transformations are a little bit different. So this is where, like, now we're looking at it adding a number. So any transformation can be written in f of x equals a b to the x, so that same function, but now we're adding c. And in this case, c is the horizontal asymptote. And because it has a new horizontal asymptote, the new vertical intercept is at the a plus that c value. So we're going to do the same steps that we did last time. So this time we have -3 1/2 to the x plus 4. So I'm going to start with identifying what's happening here. So let's start with identifying the vertical asymptote, because that's what vertical intercept, because that's what we did last time. So the vertical intercept, remember this time, is going to be at 0 and then a plus c. So 0, and then we're going to have -3 plus 4, which is going to be at 0, 1. Okay, that is my vertical intercept. So let's go ahead and graph that. Let's do it in the right color. 0, 1. So my vertical intercept is at 0, 1 now. Okay. Next, I'm going to take into account blah, 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 the rate at which it's growing. So it's growing at a rate of 1/2. So function is again decreasing. And then I also need to take into account that the horizontal asymptote, sorry. So this time the, oops. So the horizontal, was that in purple? So this time the horizontal asymptote's actually at that plus value. This one's going to, instead of being at y equals 0, it's going to be y equals 4, which means it's going to get really close to touching that line, but not actually touch it. So I'm going to go ahead and draw my horizontal asymptote there. And so what this tells me is that the graph is actually, it's going to look different, right? So the next thing I need is that clear point. And that clear point comes from setting this equation equal to 1. Set this equation equal to 1, I'm going to have 1, and then I'm going to have blah, 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 negative 3 times 1/2 plus 4, okay? So that one's staying the same. But negative 3 times 1/2, I'm just going to put it as negative 1.5. I'm going to put it as a decimal, so it's easier for us to kind of do the math with it. Plus 4, and oops, plus 4. Negative 1.5 plus 4. And then negative 1 plus, bleh, negative 1.5 plus 4 is going to be at 2.5. So this tells me that I'm going to have a clear point at 1, 2.5, because 4 minus 1.5 is going to be 2.5. So let's go ahead and we're going to graph that clear point. So what I can see here is that my graph is actually getting really, really close to the horizontal asymptote here, and which would make sense because if it's negative 3, it's got that negative sign there, then that means that my graph has been flipped over the x-axis, right? So instead of like making that shape that we had up above, it's upside down. So I have enough information now where I can graph my points. So I'm going to do just that. Oops, that's a text box. That's not what I want to do. So I know it's going to be decreasing on the left and increasing on the right. So even though this graph is actually increasing from left to right, as it approaches the asymptote, the values are getting closer. So you can almost think of them as decreasing. And it's, again, just because of that negative sign, it's kind of flipped, whether it's increasing or decreasing. Okay, but we can see that the values are getting smaller, which is what that means, is that by exponentially, the values are decreasing. All right, so the last thing that we need to do is find equations from the graph. So here we got some steps. The first step is to identify the horizontal asymptote. Remember, that's your C value. And then you're going to identify 2 clear points from the equation. The first one's going to be the y-intercept because that's just an easy one. And then one other point that you can see. Then you're going to use the y-intercept to solve for A. And then use the other point to solve for B. And then finally, write your formula. So let's start with that first step. We're going to identify my horizontal asymptote. So I'm going to draw it so you can see it, but it looks like my horizontal asymptote is at 5 because it gets really, really close to 5, but doesn't actually touch it, right? I can see that on the left-hand side of the graph. So I'm going to just write horizontal asymptote is 5. Okay, which means that in my equation, I'm adding 5 at the end, right? So next I need to identify 2 clear points. So 2 clear points. My y-intercept is 0, 2, so that's a good one. And then the next clear point that I'm going to look at is actually right here at -1, 3. That is the next clear point. The rest of them are not necessarily on dots. I mean, this one at 2, -2 looks close, but -1, 3 is definitely going to be a point on my graph. So I'm going to plug that in. And -1, 3. So now I have 2 points to work with. So I got my 2 clear points. The next step we said was to use the y-intercept to solve for a. So I'm going to do that. So my y-intercept was 0, 2. So I'm going to say 2 equals a b to the 0. Actually, you know what? Let's use the equation box. So that way there's no confusion. So 2 equals a b to the 0. And remember, plus 5. Okay? So remember, b to the 0 is just 1. So I have 2 equals a plus 5. And if I subtract 5 from both sides, I'm going to have negative 3 is equal to 8. So I have my a value. So we're pretty good. I'm going to go ahead and box that just so that way I know that like I got one of the numbers that I need for my equation. All right. And so next step is to use a to solve for b. So I'm going to take that point negative 1, 3, and I'm going to plug a in so I can solve for b. So that's a different color. It's lime green. And I know you guys hate lime green, but it's what we're doing. So now I'm going to take the point 3 equals, and we said a was negative 3, so negative 3 times b to the, and it's to the negative 1 power, plus 5. I'm going to solve for b. So I'm going to start by subtracting 5. So I get negative 2 equals negative 3 b to the negative 1. Divide by negative 3. I'm going to have 2/3 equals b to the negative 1. And then this is where you're going to take the negative 1 root. And it looks weird, but you're going to get b is equal to 3/2 because it really just splits it. Okay? Let's put that all together. So b is equal to 3/2. So now I have my b value, I have my a value, and I have my c value, which is 5, remember? So I have enough information where I can write my equation. So my final equation is f of x equals a, which is negative 3, b, which is 3/2, plus, or to the x, can't forget that, plus 5. And that makes sense. This graph has been shifted. It's obviously been reflected, and we can see that it's getting wider. It increases from left or decreases from left to right. So that is your final answer. You guys should have enough information now actually to do all of the homework, especially since you have such a long weekend. I'm hoping you guys can have lots of fun with that. All right, check Google Classroom and check the agenda to see what problems need to work.